These are the first 10 problems for the SAT practice test number 2 in the no calculator section, and it is under assignment number 10 in test prep. So on problem 1, you want to come up with the solution set to this equation. And so the thing to remember is that with inequalities, when you divide out by a negative, like you are here, you have to reverse the inequality. So it's actually going to reverse directions. The reason for that is when you divide by a negative, you're reversing magnitude. So it's like 3 is greater than 2, but negative 3 is less than negative 2. Number 2, so 2/3 of any amount of water contains hydrogen. Pretty basic idea, H2O. And so if we have 2.4 times 10 to the 25th of water, I guess is the best way to describe, then how many are hydrogen? So 2/3 times that value. You got to do this no calculator. So 2/3 of 2.4, that's what you're looking at. Oh boy, so that's 4.8, and the top divided by 3, 1.6 times 10 to the 25th. So every once in a while I have to catch myself, hey, this is the no calculator part. Problem 3, which of the following ordered pairs is not a solution? So you're basically running through all of these, and then 311 makes a false statement when you get to it. 9 is not greater than or equal to 10. Problem 4, so anytime you see the word per, that is a rate, which usually represents the slope. And a flat fee of $2, so that's your, when you're thinking of the y equals mx plus b idea. So 339x plus 2. And which one is the best representation of that? So these two are not linear functions. And so our 2 is our y-intercept, so it cannot be a. Through process of elimination, it has to be b. Okay, problem 5. So we have a system of equations. And sometimes I think the best thing is just to work with the answers you have. For sure, this is your system. So you have $1, $1.50, and $20. That's got to go together in one line of the system. And then the sum is 15. So how many hot dogs does the group order? So if you have 5 hot dogs, you got 10 hamburgers. So if you're assuming that's the right answer, substitute it in, see if you can get it to work in the top line, and it actually does. So sometimes the old guessing and checking way is better than the long drawn out algebra, although you can do the long drawn out algebra. And so I use the method of substitution, in which you have to do some multiplying out. So solve for y, replace that up in the y piece, multiply the 1.5 through, collect your like terms, divide it out. I really think the guessing and checking is probably a better way. Problem 6. So solve for x. This is just dealing with formulas. So subtract b. You want to isolate the term that contains the x variable, and then divide by m to get x. Problem 7. Okay, so we have a flat fee of $10 and then $7 per visit. So there's that word per again, which gets at the idea of a rate. And then the other one, just a flat fee of $100 per month. So how many times, must you visit the gym in order to benefit from purchasing a membership? So you have to set them equal to each other. And 12 won't quite do it. You want it to be 13, because with 13, the top would be 91 plus 10, 101. So then purchasing the membership for $100 would be better. So 13 is that choice that you want to make there. Problem 8. So this is about the discriminant being 0. And you have to kind of know this because you don't have your graphing calculator here. So which one of these has a discriminant equal to 0? You can probably factor too. I put best there. Try to do some factoring, and you'll notice that as you try to factor, only C factors. So that's probably what you're most familiar with. But you have to answer the question. So you get -1 twice. It's really only one solution. Or you can do the discriminant out for each one. So probably the factoring is going to get you the best answer. Problem 9, this one is a thinker. So how much money can Andre spend on each meal? So you have to figure out, I use some numbers here, but you have to really think about, all right, how much does he have left after he spends the money on tickets? So number of students times the value of each ticket. He's at $200 total. So if you take that difference, that's the amount of money he has left to spend on meals. And so per meal, you would divide by the number of students. That's the best way to think about that. Again, the 200 minus TS is the amount of money left to spend on meals divided by the number of students. Then you'll know how much he has left. So in my number system that I picked, he would have $150 left to spend on meals, $50 on tickets, and then so 150 over 50 is $3 per meal. So using the old numbers game is important. This is kind of a hard problem, but what I would tell you to do is notice on number 2, and you got to know what the heck is the 4 through to 16, and how do you reduce the square root of 8, 2 times the square root of 2. You got to kind of know how to reduce square roots. So this is the one that, they put these hard ones on here to separate the weak from the, well, I don't say the weak, but the less able math students from the good math students, the great math students, we'll say. And so the best way to approach it, the 4 through to 16 is 2. So none of these others reduce to 2. That's probably the best way to think about this. And then this here is 4 squared times 4, which is 64. And then there's no 4 through to 64, something times something times something times something. So they all break down as 2 times the square root of 2, 2 times the square root of 2x. So C is the one that's different. That's a hard problem. So again, they throw these in there to see how can we make a difference in deciding the top students from a batch of good students.